The Sun, a blazing ball of plasma that dominates our sky. This celestial body is not just a source of light, it is a powerhouse of energy, constantly churning and burning, providing the essential ingredients for life on Earth. The Sun's surface is a dynamic and ever-changing landscape with solar flares and plasma eruptions that can be both mesmerizing and terrifying. It is the center of our solar system. All the planets, including our Earth, revolve around this magnificent star, held in place by its immense gravitational pull. The Sun's gravity is so strong that it governs the orbits of all the celestial bodies in our solar system, from the smallest asteroid to the largest planet. Life on Earth depends on it. Without the Sun, our planet would be a frozen wasteland, devoid of life. The energy from the Sun drives photosynthesis, the process by which plants produce food, and in turn, supports the entire food chain. It also regulates our climate and weather patterns, making Earth a habitable place. The Sun's energy fuels our plants, drives our weather, and bathes us in light and warmth. Every ray of sunlight that reaches Earth is a testament to the Sun's vital role in sustaining life. From the lush forests to the vast oceans, every ecosystem on our planet is intricately linked to the Sun's energy. But have you ever stopped to consider just how massive our Sun truly is? It's easy to take the Sun for granted, seeing it as just a bright spot in the sky. However, its size is truly staggering when you start to think about it. The Sun is not just a large star, it is a colossal giant in the cosmic scale. The Sun is so large that it could contain roughly 1.3 million Earths within its volume. Imagine lining up Earths one after another and still having room for more. This comparison helps us grasp the sheer enormity of our star. The Sun's diameter is about 109 times that of Earth, making it a truly gigantic presence in our solar system. Imagine that for a moment. Our planet, which seems so vast to us, becomes a mere speck when compared to the immense scale of the Sun. This perspective shift can be humbling, reminding us of our place in the universe and the incredible forces at play. Our planet, which seems so vast to us, becomes a mere speck when compared to the immense scale of the Sun. This realization can be both awe-inspiring and humbling, as it puts into perspective the grandeur of the cosmos and our place within it. This essay will delve into the science behind this mind-boggling fact. We'll explore the physics and mathematics that help us understand the Sun's size and its impact on our solar system. From the principles of gravity to the concept of sphere packing, we'll uncover the scientific marvels that make the Sun such a fascinating subject of study. We'll explore the concepts of size, volume, and sphere packing. These scientific principles allow us to comprehend the vastness of the Sun and its capacity to hold such an enormous volume. By understanding these concepts, we gain a deeper appreciation for the complexities of our universe. We'll uncover the Sun's vital role in our solar system. From influencing the orbits of planets to driving the climate on Earth, the Sun's presence is felt in every aspect of our lives. Its gravitational pull keeps the solar system in harmony, while its energy sustains life on our planet. And we'll gain a newfound appreciation for the star we call our own. As we delve deeper into the science and beauty of the Sun, we'll come to understand just how fortunate we are to have such a magnificent star at the center of our solar system. The Sun is not just a source of light and warmth, it is a symbol of life and a reminder of the wonders of the universe. To comprehend the sheer size difference between the Earth and the Sun, we need to delve into some fascinating details about their dimensions and volumes. Let's start with their diameters, which is a straightforward way to begin understanding their scale. The diameter of a sphere is the distance straight through its center, from one side to the other. This measurement gives us a basic idea of the size of a spherical object. Earth's diameter is about 7,917 miles. This might seem huge, but it's just a tiny speck compared to the Sun. The Sun's diameter is a staggering 864,000 miles. To put that into perspective, the Sun's diameter is more than 109 times that of Earth. That means you could fit 109 Earths side by side across the face of the Sun. Imagine lining up 109 Earths in a row. That's how wide the Sun is. But diameter only tells part of the story. To truly grasp the enormity of the Sun compared to Earth, we need to look at volume. Volume is the amount of space that an object occupies. It's a three-dimensional measure that gives us a better sense of the overall size. To understand how many Earths could fit inside the Sun, we need to consider volume. Think of it like this. If the Sun were a giant empty container, how many Earths could we fit inside? The volume of the sun is so immense that you could fit about 1.3 million Earths inside it. Yes, you heard that right, 1.3 million. This gives us a true sense of the colossal scale of the sun compared to our home planet. So while the diameter gives us a linear perspective, the volume reveals the true vastness. The sun is not just wider, it's exponentially larger in every dimension. Understanding these differences helps us appreciate the scale of our solar system and the incredible forces at play. The sun, with its massive size, plays a crucial role in the dynamics of our solar system, influencing everything from the orbits of planets to the climate on Earth. So next time you look up at the sky and see the sun, remember that it's not just a bright light. It's a gigantic, powerful star that dwarfs our planet in every conceivable way. This tale of two sizes, Earth and the sun, reminds us of the vastness of the universe and our place within it. It's a humbling and awe-inspiring perspective. Calculating the volume of spheres like the Earth and the sun involves a bit of math, but the result is astounding. The sun's volume is about 1.3 million times greater than Earth's volume. That means you could fit approximately 1.3 million Earths inside the sun. It's hard to truly grasp the enormity of this number. Imagine filling a large stadium with Earths. Now imagine 1.3 million of those stadiums all filled with Earths. That's how many Earths it would take to fill up the sun. However, there's a slight catch to our 1.3 million Earths calculation. We've been imagining packing Earths into the sun like we're filling a jar with marbles. In reality, when you pack spheres together, there's always a bit of empty space between them. This concept is called sphere packing. Because of those tiny gaps, we couldn't quite fit 1.3 million Earths into the sun without squishing them. The actual number is slightly less, but it's still incredibly impressive. So, what is it about the sun that allows it to be so massive? How does it maintain its colossal size and incredible energy output? Well, the sun is mostly made up of hydrogen and helium. These two elements are the building blocks of the sun, making up about 98% of its mass. These are the two lightest elements in the universe. Hydrogen, the simplest and most abundant element, and helium, the second lightest, play a crucial role in the sun's structure and behavior. But don't let their lightness fool you. Despite being light, they are present in such enormous quantities that they give the sun its immense mass and volume. The sun contains a staggering amount of hydrogen and helium. Imagine billions upon billions of these tiny atoms packed together, creating the powerhouse that is our sun. In fact, it's estimated that the sun contains about 99.86% of the total mass of our entire solar system. This means that almost all the matter in our solar system is concentrated in the sun. Deep within the sun's core, the intense pressure and heat cause hydrogen atoms to fuse together. This fusion process is what powers the sun and produces its energy. This process, called nuclear fusion, releases an incredible amount of energy. When hydrogen atoms fuse to form helium, they release energy in the form of light and heat. It's this energy that powers the sun and bathes our solar system in light and warmth. Without this continuous energy output, life on Earth would not be possible. The sun's energy drives weather patterns, ocean currents, and even the growth of plants through photosynthesis. The sun's energy is also harnessed by humans in various ways. Solar panels convert sunlight into electricity, providing a renewable source of energy. The sun truly is the heart of our solar system, sustaining life and driving the processes that make our planet habitable. Section 6. The sun's gravitational embrace. The sun's immense mass also gives it a powerful gravitational pull. Gravity is what holds our solar system together. It keeps the planets in their orbits around the sun. And it's the reason why we don't just float away into space. Think of the sun as a giant anchor holding all the planets in place. Without the sun's gravity, our solar system would simply fly apart. Section 7. The heart of the sun's furnace. The sun's energy comes from its core, where temperatures reach a scorching 27 million degrees Fahrenheit. That's about 15 million degrees Celsius. At these extreme temperatures, hydrogen atoms are constantly colliding and fusing together to form helium. This fusion process releases a tremendous amount of energy in the form of light and heat. This energy then travels through the sun's layers and eventually radiates out into space, reaching us here on Earth. Section 8. The sun's long goodbye. The sun is about 4.6 billion years old. That's about halfway through its lifespan. Eventually, the sun will run out of hydrogen fuel in its core. When this happens, the sun will begin to expand and cool, transforming into a red giant star. As a red giant, the sun will engulf the inner planets, including Earth. But don't worry, this won't happen for another 5 billion years or so. Section 9, a star among billions. Our sun is just one of billions of stars in the Milky Way galaxy, and the Milky Way is just one of billions of galaxies in the observable universe. The sheer scale of the cosmos is truly mind-boggling. The next time you look up at the sun, take a moment to appreciate its immense size and power. It's a star that sustains us, warms us, and reminds us of the vastness of the universe we inhabit.